Ethers are organic compounds having the formula ROR prime, where R and R prime represent an alkyl group. Okay. So these are alkyl groups, and the two alkyl groups are connected by an oxygen group. Okay. So we call this oxy for short. So two alkyl groups are connected by an oxygen group. Okay, so we call that those kind of compounds, we call them ethers. So most students mistake ethers for esters. Okay, esters have the molecular formula RCOOR prime. So it's quite different from that of ethers. Ethers only have two alkyl groups connected at the center by an oxygen group, which we call oxy for short. Let's take, for example, I have an ether like this. I have CH3O and CH3. You can see here that this is an alkyl group called what? Called methyl. It's also an alkyl group called methyl, and they are connected at the center. And what I call that center, I said oxygen, right? And we use the short form oxy. Okay, so if you are to name this ether, you say this is an ethyl, this is also an ethyl. So I can call this, how many ethyls do we have here? Two. And in chemistry, we use the word di for two. So we say dimethyl, then add the name ether. So it becomes dimethyl ether. Take for example, I have C2H5 or C2H5. Again, this is an ether, right? We have two parts. This part is an ethyl. This is ethyl, and this is also what's ethyl. Okay, connected at the center, oxygen. So this is ethyl and ethyl. So we have two ethyls that will become diethyl ether. Very simple. Let's see something else. Let's take for example, I have CH3 or C2H5. Okay, again, this is an ether, so this is methyl, and this is ethyl. All right, so and they're connected at the center, so we call this an ether. So we call this should be methyl ethyl, but if you arrange it alphabetically, we say this is ethyl, since E comes first, ethyl, methyl, then ether. I think you get the idea. So this is how you name ethers. Although this sense of naming, this idea of naming is, this is just the common name for ethers. Okay, so the IUPAC name, the way you name ethers now correctly, I'm talking about IUPAC nomenclature now, is this way. Okay, take for example, I have CH3 or C2H5. That's this one. This one I called ethyl methyl ether. Let us rename it now. This is just the common. This is just the common name. So let's rename this using IUPAC nomenclature. IUPAC, IUPAC nomenclature. So the idea is very simple. I'll just give you a simple rule. The thing is, when you name normal organic compounds like alkanes and the rest, what do we consider? We consider the parent chain, okay, and we consider the substituent, okay. We always say that the parent chain is the longest carbon to carbon chain is a parent chain, while the other one that is not the longest, obviously maybe the shortest, is the substituent. Do you understand? So looking at these two alkyls, this is methyl, and this is ethyl. All right, now which of them is the longest? Obviously this has two carbons, so this over here is the longest, right? Has the longest carbons, so we say that the longest is the parent. And don't forget that alkyls are not parents. Alkyls are always what? Substituent. The only parent we can have alkanes. Alkanes can function as a parent, alkenes, alkynes, and the rest. So we are going to revert, since this is the parent, now we're going to revert it back to its parent state, which is what? Which is ethane. So the parent here is what? Is ethane, which means that this other part, which is a CH3 O, is our what now? Is our substituent. Do you understand? Let me bring it out. CH3O. This is our substituent. What do we call this part? We call this part methyl. And what do you call this part? Let me highlight that. What do you call this part? This is oxy. I mentioned that up here. So this is oxy. So when you combine methyl and oxy, it forms a new word, methoxy. It forms a new word, methoxy. So methoxy is our what now? Is our substituent. While ethane is the parent. So the name of this compound, which I formally named as ethyl methyl ether, the IUPAC name is methoxy methoxyethane. I think that's clear. Methoxyethane. Now, usually when you name organic compounds, we usually tell the position of the substituent. Since methoxy is a substituent, so we have to tell the position of the substituent. That's the position of at which the substituent is attached to the parent. If I draw this compound, do something like this: CH3O attached to C, then H5. So this part is the parent, right? So where's the first carbon here? The first carbon always comes from the oxy group. So this is the first carbon. This is the second carbon in the parent chain. So you can see that the substituent here, which is methoxy, is attached to the first carbon. So we say this is 1-methoxyethane. Take a look at this one we named here, which we called it dimethyl or diethyl ether. So let's see the IUPAC name, CH2 C2H5 or C2H5. Okay, so how do you name this now? That's IUPAC nomenclature. The first thing to do is to identify the parent chain, and don't forget the parent chain is the what? Is the longest carbon chain from the oxy group. So which of them is the longest? Okay, okay, they look alike. They are exactly the same. We have two here, we have two here. So any of them. So let me pick this one. It looks finer. So this one now is my what now? Is my parent. Okay, if this is my parent, it means that this over here is my substituent. It's my substituent. I think that's clear. So the name of the parent, this is ethyl, but I told you it's going to revert to its parent form, which is what? Ethane. Which is ethane. And this substituent, what do you call this part of the substituent? This is ethyl, right? Ethyl. And O, we have O in between them. O is part of the substituent as well. O we call O oxy. So if you combine oxy and ethyl, it becomes ethoxy. Let me spell that correctly. It becomes ethoxy. Remove the eel and add your oxy, so it becomes ethoxy. So ethoxy is my substituent. So the name of this compound is obviously saying dimethyl ether. We can call this ethoxyethane. And also don't forget that the ethoxy is a substituent and is attached to the first carbon here. So then we call this 1,1-ethoxyethane. Similarly, where is it? Similarly, where we talked about this one, where we add CH3OCH3. Initially, we call this dimethyl ether. This is the simple name or the common name. So the IUPAC name, again, identify the longest. The longest is, okay, again, they are the same. So we have the same number of carbon. So just pick one. Let's say this one is the parent. So we call this methyl, right? But to return back to it, since the parent, to return back to the parent state, which is what now? Which is methane. All right. So this part now is my substituent. Everything here is my substituent. CH3 is methyl and O here is oxy. So together it becomes methoxy. So methoxy now is my substituent. Okay, so what will be the name of the compound? This will become methoxy. So remove the L. Methoxy methane. And again, the substituent methoxy is attached to the first carbon of the parent, which is methane. So we say 1-methoxy methane. Okay, so let's take a look at this ethers. They are ethers, right? Because we have alkyl on both ends connected by an oxygen atom, which is oxy. I mentioned that already. So let's name this using IUPAC nomenclature. So I said the first thing you have to do is identify the what now? The parent chain. And the parent chain is the longest carbon chain. So let's see, we have a carbon here, we have a carbon here, a carbon here, a carbon here, a carbon here, and a carbon here. On the right hand side, we only have two carbon atoms. On the left hand side, we have one, two, three, four. So obviously, the longest is this. So this here will be my parent. Okay. So four carbons, one, two, three, four. Normally it's supposed to be butyl, but since it's the parent, you call this what now? You call this butane. So this is the parent. So let's see the substituents now. Everything here, let me use a different color for that. Everything here is the substituent. First, let us name the alkyl part. The alkyl part, there are two carbons. Two carbons, that is ethyl. So this part is ethyl. And what I call this oxygen, I call that what? Oxy. So combine them, this will give me ethoxy. Sorry, let me spell that correctly. That will give me ethoxy. So the name of the substituent is ethoxy. Now let us number the parent chain. The parent chain, this is the first carbon. So this is number one, number two, number three, and number four. You can see that ethoxy is attached to the first carbon. So we say this is one ethoxy, one ethoxybutane, one ethoxybutane. So let's see this other one over here. Again, we have carbons. We have this is a carbon, a carbon, a carbon, a carbon, a carbon, a carbon. Again, the parent chain is the longest carbon to carbon chain. So let's see which is the longest. This is one, two, three, but this is one, two. You're forming a chain here. This one does not form a chain. Okay, so obviously that means that this carbon, the carbons here are the longest. So let's number the chain. This is the first carbon, number one, number two, and number three. So this is the longest. So what do you call this? Three. That will be propane. This is propane. So let's name the substituent. Okay, methyl. Right. I'm trying to tell the position of this methyl. So this is one methyl, and the name of this part is ethyl, right? Ethyl now is attached to oxy, so it's become ethoxy. So this is one methyl ethoxy. One methyl. Why do you know why it is ethoxy? Because the longest chain is ethyl attached to an oxy group, that's ethoxy, and we have a substituent attached to the ethoxy, which is on number one carbon of the ethoxy. So that's why I said one methyl ethoxy, and the name of the parent is propane. So this becomes one methyl ethoxy propane. Now the substituent is what? This everything over here, everything there is the substituent. And where is it attached? That's this, Sabi. Where is it attached? It's attached to the first carbon of the parent. So we put all the substituent in a bracket like this and put one. This is one. This one here is telling us that the substituent, which is one methyl ethoxy, is attached to the first carbon of the parent propane. Okay, let's take a look at this. We have one, two, three, four, five, six, seven. So again, the longest chain is the parent chain. So let's see. This is just two. This is one, two, three. So obviously this is the longest chain. So let's name the longest chain. The longest chain, we have three carbons, right? We have one, we have two, and we have three. Okay, we have three. So three is propane, but we have some substituents. We have this here, methyl, and we have methyl. These two methyl are attached to the first carbon, so we say that is one dimethyl, and the name of the longest chain is three. That's propane, right? So the name of the parent here is one dimethyl propane. What about the substituent? This here, everything here is the substituent. This part is ethyl and this part is oxy, so it becomes ethoxy. So we can add that at the front here as ethoxy. Sorry for the space. Let me bring it closer. Ethoxy. Where the ethoxy attached to is attached to the first carbon of the parent, so we put a one. This is one ethoxy, one dimethyl propane. All right, finally, let's see this example. We have a carbon here, have a carbon here, have a carbon here, a carbon here, a carbon here, and a carbon here. Again, the parent, I've repeated this like three times now. The parent is the longest carbon to carbon chain. Okay, so let's count. This is one, two, three. This is obviously the longest. So, so this here is my parent. So we have 4 carbons. Let's number the carbons. This is number 1, number 2, number 3, and number 4, which means that my parent is butane. My parent is butane. So every other thing you see, every other thing here is my substituent. So let's name the substituent, shall we? Okay, the longest chain is 2. That's ethyl. That's ethyl. Okay, so at this part here, 2 carbons now. That's ethyl. Ethyl is attached to oxygen, so it becomes ethyl oxy. That's ethoxy. So ethoxy. Do you get that? But now we have some other substituents. We have bromine. The bromines now are, this is the first carbon on the ethoxy, this is the second carbon. Where are the bromines on? They're on 1 and 1. So we say 1 1 dibromo bromo. There's not much space. So 1 1 dibromo ethoxy. This here is the what now? This here is the name of the substituent attached to the parent. So we add the parent at the back, it becomes butane. So the name of this compound is 1 1 dibromoethoxybutane. But now my substituent is on the first carbon, so we put a 1 outside. So it becomes 1 1 1 dibromoethoxybutane. In the next video, we'll talk about crown ethers. We'll talk about simple reactions of ethers like the Williamson ether synthesis, and we'll talk about acidic cleavage.